All right, people. I believe everybody is doing great, nice, and absolutely fine. So, welcome to Unacademy NEET English. Make sure everybody of you have marked the attendance. Okay, that is by smashing the like button. Do it as soon as possible. Okay, because marking the attendance is extremely mandatory. Okay, so do smash the like button. Okay, and when it comes to the chapter that we are starting over here in this particular case, that is electrostatics. Okay, we will be talking about the chapter electrostatics from the scratch, from the basics. Okay, I'll be teaching you this particular chapter. And my dear friends, when it comes to the class 12th, this is your first chapter of class 12th. This is the first chapter of class 12th. So I would want you guys to give me the 100% attention. Okay, so I'll be starting this particular chapter from the scratch. And when it comes to the NEET examination, we can say 4 to 5 questions are asked from this particular chapter. We say 4 to 5 questions. 4 to 5 questions are asked from this particular chapter. Keep that thing in your mind. Keep that thing in your mind. Okay. Now, guys, when it comes to the electrostatics, we say, what does electrostatics actually mean? Electrostatic means, let's suppose you have got a charge. What is this charge that we need to study after some time? When the charge is exactly at rest, okay, we study charges at rest in this particular chapter. Okay, like after some time I'll be telling you, sir, this charge will create electric field around it. Okay, when this charge is placed in the external electric field, it is force acts on this. Now, the very first topic that I need to understand, that we need to understand, is electric charge. Okay. Now, guys, take a look what this electric charge is all about. See. Let's suppose we are doing an experiment. Let's suppose I'll take a comb over here. Okay, that basic example I'll be taking. This is a comb. Okay, the comb by which we make the hairstyle. Okay. Now, my dear friends, I'm taking this comb. I'm rubbing this comb with my hair, something like this. Okay. Then I'm taking it near to the piece of papers. I have placed small piece of papers over here. These are the small piece of papers. Okay. So I have in this particular case a comb which I'm rubbing with my hair, and then I'm placing a small piece of papers over here. When I take it near to the piece of papers, these piece of papers are attracted to the comb. Okay, they'll stick to the comb. These are attracted to the comb, and these piece of papers will stick to the comb. If I ask you why does these piece of paper stick to the comb? Sir, when you rub the comb with your hair, something gets occupied onto this comb. Due to that something, these piece of papers are attracted. That something which gets occupied on your comb due to the rubbing, so that is what we call electric charge. Okay, that is what we call electric charge. I'll write the statement over here. When a comb is rubbed, with hair, charge gets occupied on it. And due to that charge only, it starts attracting the piece of papers. So can I say, charge is something due to which a body shows electrical and magnetic effects. Magnetic effects means it is attracting the piece of papers, the magnetic effect. So I can say, so charge is the property. Due to which when charge occupies on a body, it attracts the another body, due to which a body shows electrical and magnetic effects. magnetic effects, due to which a body shows electrical and magnetic effects. So charge is something due to which a body shows electrical and magnetic effects, due to which a body shows electrical and magnetic effects. Like here. These piece of papers are attracted. When you rub the comb with your here, charge gets occupied onto the comb. Then only the piece of papers are attracted. So that's why this attraction takes place. That's why this attraction takes place. Now, my dear friends, when it comes to this charge, okay, we say this charge is of two types. Okay. The first one we say positive charge, and then we say negative charge. We say charge is of two types, positive and negative. Now guys, let's suppose if you place a positive charge here and you place another positive charge here, we say the two positive charges will repel each other. Okay, they repel each other. Why? Because we say like charges repel each other. Okay. Now my dear friends, if let's suppose I keep a positive charge over here, I keep a negative charge over here, we say unlike charges attract, so they attract each other. Unlike charges attract each other. Now my dear friends, if you have a negative charge here, if you have a negative charge over here, we say then two negative charges actually repel each other. The two negative charges repel each other. Okay. So like charges repel, unlike charges attract. Keep this thing in your mind. Now, one more important thing that I want to say in this particular case. What is that? When it comes to the symbol of charge, we say symbol of charge is Q. Okay. Like you say mass, symbol of mass is M. You say M is equal to 2 kg, M is equal to 3 kg, M is equal to 4 kg. Similarly, we say symbol of charge is actually what? Q. And when it comes to the SI unit of charge, SI unit is coulomb. Okay, SI unit is coulomb. You do not say, sir, let's suppose this is a sphere. We say, sir, how much charge is present on the sphere? You say, sir, Q is equal to 2 kg charge. Is this correct or incorrect? It is incorrect. So we say here, sir, it is 2 coulomb charge. Sir, it is minus 3 coulomb charge. Sir, it is minus 8 coulomb charge. Okay, because SI unit, we measure the charge in coulombs. Symbol is Q. There are two types of charge, positive and negative. Two positive charges repel each other. Unlike charges attract each other. Okay. I hope this is crystal and clear till over here. I hope this is crystal and clear till here. Yes. Now, my dear friends, let's talk about one more thing. Before this, I just want to say, what is that? See guys. When it comes to an atom, please do remember this particular thing. When it comes to an atom, we say everything in this universe is made up of small tiny particles called atoms. Okay, this is also made up of atoms. How does this atom actually look like? See, we say at the center of the atom, it has got nucleus. This is the nucleus. Okay, and around the nucleus, always remember, around the nucleus, we say electrons are revolving around the nucleus in the orbits. Okay, we say electrons are revolving around the nucleus in the orbits. Okay, like guys, this is nucleus. Inside the nucleus, you have got protons and you have got neutrons. Sir, what are these protons? Always remember, when it comes to an proton is a particle which has got positive charge. Okay, proton is a particle which has got positive charge. Okay, and there is one more particle which is called electron. Electron is that particle which has got negative charge. It has got negative charge. So my dear friends, if I say from now onwards, negative charge is present on this pen, what does that mean? We say excess of electrons is present over here. Okay, okay. And when it comes to the positive charge, means protons. Protons means positive charge. Deficiency of electrons. Okay. And then you have neutrons. Neutrons do not have any charge. They are neutral. Okay, neutral. Neutral. Now, guys, so inside the nucleus, it has got protons plus neutrons. Protons have got what charge? Positive charge. Neutrons are neutral. And around this nucleus, we say electrons are revolving. Electrons are revolving. Electrons have got the negative charge. And if you say, sir, how much is the charge on proton? Okay, charge on proton is going to be plus 1.6 into 10 raised power minus 19 coulomb. And if you ask me, what is the charge on an electron? You say, sir, that is minus 1.6 into 10 raised power minus 19 coulomb. So charge on proton is positive, and when it comes to the charge on electron, it is negative. Charge on proton is positive, charge magnitude wise it is same, nature wise it is opposite. Over there it is positive, and on electron it is negative. And on electron it is negative. Okay. 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 Now, my dear friends, let's talk about a neutral body. Let's suppose we have got a rod over here. This is the rod that I'm having. Okay, this is the rod. Now, my dear friends, always remember, if the amount of positive charge on the rod is equal to the amount of negative charge, the body is said to be neutral. If number of positive charge is equal to number of negative charge, then body is said to be neutral. And neutral body means in which net charge is zero. Keep this thing in your mind. Neutral body is that body in which net charge is zero. Okay. And my dear friends, when it comes to the positively charged body, if the amount of positive charge is greater than the amount of negative charge, we say here, positive charge is greater as compared to negative charge. So if Q positive is greater than Q negative, in that case, body is positively charged. Positively charged. Keep this thing in your mind. And when it comes to the negatively charged body, we say, if the amount of negative charge is greater than the amount of positive charge, okay, if the negative charge is greater than positive charge, in that particular case, we say it is negatively charged. It is negatively charged. In that particular case, it is negatively charged. It is negatively charged. Simple thing, simple thing. Now guys, listen to me very carefully. I'll tell you how do we exactly make a positively charged body. Let me give you the crystal clear feel. See guys. Let's suppose we take an atom over here. Okay. This is the nucleus of the atom. And around the nucleus, we have electrons revolving. Okay. Around the nucleus, you have got electrons revolving. Okay. Now, my dear NEET aspirants, this is the nucleus. Inside the nucleus, you have got protons plus you have got neutrons. Okay. And let's suppose if I'm saying here inside the nucleus, it has got 4 protons, it has got 4 neutrons. And outside the nucleus, we say 1 electron, 2nd, 3rd, and 4th. 4 electrons are revolving. We say 4 protons are inside the nucleus. Could you please tell me how much is the positive charge and how much is the negative charge? Can't you say in this particular case, guys, here positive charge is equal to negative charge. In this case, you have got 4 positive charge, neutrons are neutral. You have got 4 electrons, means 4 negative charge. Can I say here, net charge is 0? Because if the amount of positive charge is equal to the amount of negative charge, we say net charge is 0. We say net charge is 0. Okay. And the body is said to be neutral. Now, my dear friends, listen to me very carefully. We have to make it positively charged. See what we can do. What I want you guys to do is, we say remove 1 electron. Sir, how can you remove one electron? By any means, you can remove 1 electron. Okay, we don't have to discuss that. So you are basically removing 1 electron in this particular case. Okay. You are removing 1 electron in this particular case. Take a look. Okay, just a second, I'll copy it. Okay. Okay, let me keep it here only. Let me make the new one. So here, what I'm going to do is, so again, this is the nucleus, and this is the first orbit, and this is the second orbit. Now, guys, take a look. How many number of protons? We say 4 protons. We have got 4 neutrons. When you remove 1 electron, how many electrons? 1 electron, another electron, another electron. Now, could you please tell me, in this particular case, sir, can I say positive charge becomes greater than negative charge? When the amount of positive charge is greater than the amount of negative charge, we say net charge on the body is negative. We say net charge on the body is negative. And the body is said to be negatively charged. In that case, we say body is said to be negatively charged. So, on removing an electron from the atom, we say body becomes negatively charged. Now, when it comes to, body becomes positively charged. Sorry. In this case, net charge is positive. We say net charge here is positive. Why? Because positive charge is greater than negative charge. So, it becomes positively charged. Now, my dear friends, take a look. When it comes to the negatively charged body, let's suppose I'll make the atom once again. This is the nucleus. Around the nucleus, this is the first orbit. Okay. And you have got second orbit. Okay. Now, in this particular case, you have got 4 protons, you have got 4 neutrons. And you have got electron. Yes. Now, what I want you guys to do is, and when it comes to this, can I say in this particular case, net charge is 0? Why? Because the amount of positive charge is equal to the amount of negative charge. And this is neutral. So guys, my dear friends, in this particular case, what I want you guys to do is, I'm saying supply 1 electron to it. Okay, supply 1 electron. Previously, you removed 1 electron. But right now, I'm saying supply 1 electron to this particular atom. Then, my dear friends, you can take a look exactly over here. This is the nucleus. And around the nucleus, okay. So you have got 4 protons, you have got 4 neutrons. Now this is electron, okay. This is the electron, and 1 more electron. Now in this particular case, can I say, guys, negative charge becomes greater than positive charge? And if this happens, why? Because 5 electrons are over here, only 4. So we say this body becomes negatively charged. And my dear friends, when body becomes negatively charged, We say here in this particular case, net charge will become negative. Net charge will become, okay. Guys, if you ask me, sir, why cannot we remove and add the proton? Protons are inside the nucleus. It is very difficult to remove and add the proton when it comes to an atom. So that's why we keep on adding or removing the electron only. So by adding the electrons, we say negative charge increases. So if negative charge, yes, exactly. If negative charge becomes greater than positive charge, we say in that particular case, body becomes negatively charged. Okay. Okay. And that is the reason we say positively charged. Guys. Can I say a positively charged body means deficiency of electrons? Why? Because electrons are less. Deficiency of electrons. Okay. It means deficiency. Deficiency of electrons. Okay. That is what we call that is the actual definition of positive charge. And when it comes to the negative charge, it means excess of electrons. Excess of electrons. Okay, that is what we call the negative charge. Negative charge means excess of electrons. Positive charge means deficiency of electrons. If you have more number of electrons, means it is negatively charged. Okay. If you have less number of electrons, it is positively charged. As simple as that. Now comes the properties of a charge. Now comes the properties of a charge. Okay. Now comes the properties of a charge. The very first property is charge is conserved. Charge is conserved. Okay. Charge is conserved. Okay. Will you cover every topic in this session? Not every topic. Okay. We will not cover not every topic. Okay. Keep that thing in your mind. And guys, make sure you smash the like button because liking the session is mandatory. Okay. Okay. Now guys, take a look exactly in this particular case. See, we say properties of charge. Charge is conserved. What does that mean? See guys. Let's suppose you have taken a box. Let's suppose you have got a box. Okay. Inside the box, you have got 3 balls. This is the first ball, second ball, third ball. Okay. Now, my dear friends, could you please tell me what is the net charge on this ball is 2 coulomb. Charge on this ball is 3 coulomb. Charge on this ball is 4 coulomb. If I ask you what is the net charge inside this box, you say 4 plus 3, 7, 7 plus 2 is 9. So plus 9 coulomb. Okay. Now, what you are doing is that you are taking this box and you are taking it to the another place. Okay. You are shaking it. You are throwing it up. Then it falls down. Okay. Then take it to the another place. Now, my dear friends, when you do that, after some time, when you open the same box, you see on this ball, right now, 3 coulomb charge has occupied. Previously, how much charge was there on the ball? 2 coulomb. On this ball, you see 1 coulomb charge is present. Previously, it was 3 coulomb. And on this third ball, 5 coulomb charge. If I ask you what is the net charge inside this box, 5 plus 3 is 8, 8 plus 1 is 9, plus 9 coulomb. Can I say, sir, net charge of this particular system is conserved? Whatever is the net charge initially, same is finally. No doubt the balls inside have shared, these spheres inside have shared the charge between each other. But when it comes to this, net charge remains conserved. Okay. Now, my dear friends, I can write over here. Charge is conserved means net charge of the system remains conserved. whatever is the charge initially, same is the charge finally. Net charge, net charge. Between the two balls, the two spheres can share the charge, the two bodies can share the charge between each other. But when it comes to the net charge of the system always remains conserved. That is what we call the conservation of charge. That is what we call the conservation of charge. Now guys, one more important thing. Let's suppose you have got this one in this particular case. Okay. Guys, here. You take a look at this particular system. On this sphere, you have got plus 5 coulomb charge. Okay. Now, my dear friends, you have got minus 2 coulomb charge over here. So basically, when you touch these bodies, they share the charge between each other. Now, this is plus 5 coulomb. This is minus 2 coulomb. How much is going to be net charge in this particular case? You say plus 5 minus 2. That is going to be how much? That is 5 minus 2 is 3. So that is going to be plus 3 coulomb. Now guys, tell me in this particular case, means when this body is touched with this, it has shared how much charge? Plus, it has given it to a plus 2 coulomb charge over here in this particular case. Okay. Now, let's suppose if this happens, we say finally, initially charges net is how much? We say plus 3 coulomb. Okay. How much is the charge finally? Sir, finally also net charge must remain conserved. Now, we say, sir, on this body, it is plus 3 coulomb and it has shared the charge of how much? We say if 2 coulomb has shared over here, so this becomes neutral in this particular case. Okay. Now guys, one more important thing I just want to say over here, that is conservation of charge. Okay. Does mass of a body change upon the charge? Yes. If charge is transferred to some body, we say mass. Charge has got electron, has got mass. So if you are transferring the electron, means you are transferring the mass. Okay. Now, my dear friends, take a look in this particular case. Okay. Okay. Now, in this particular case, what I'm trying to say is that, see, charge is conserved. What does, okay, charge is quantized. What does quantization of charge mean? What does quantization of charge mean? What does quantization of charge mean? Now see, in this particular case, when it comes to the quantization of charge, listen to me very, very, very carefully. We say it means charge is quantized, means charge is available in the fixed amounts. Exactly. I would write over here, charge is available in fixed amounts. It means charge is available in fixed amounts. Like, my dear friends, see. If you go to the market, okay, if you go to the shopkeeper, you ask him, give me a pen, he will give you 1 pen. You ask him, give me 2 pens, he will give you 2 pens. You ask him, give me 3 pens, he can give you 3 pens. But if you ask him, give me half of a pen or give me 2.5 pens, is it possible? No, sir. Why? Because 0.5, half of the pen is not possible. He cannot break the pen. It is of no use then. So we say pens are available in the fixed amounts. Similarly, if you go to the another shopkeeper, you ask him, give me 2.5 kg of rice. Is it possible? Yes. Okay. Okay. If you ask him, give me 3 kg of rice. Yes. Give me 0.75 kg of rice. Yes. Okay. We say, when it comes to the rice, it is available in random amounts. You can get the rice in any amount. But when it comes to the pen, that is available in fixed amounts. Similarly, we say charge is available in fixed amounts. Okay. Now, my dear friends, listen to me very carefully. If you, sir, what is the smallest charge that is available in this world? We say, sir, the smallest charge is charge on an electron. Sir, can you get one electron? Yes, this is the smallest charge, okay, E, charge on an electron, charge on an electron. This is the smallest charge available, okay. Now, if somebody says, sir, charge on, we say quarks, okay, is less than the charge on an electron. No, those are not the fundamental particles. Quarks do not exist individually, but electron does. Now, my dear friends, we say charge on an electron is the smallest charge available. So if you go to the market, if you buy, let's suppose there is a shop, imagine it is selling the charge. So if you ask the shopkeeper, give me one electron, he will give one electron. 1.6 × 10⁻⁻19 coulomb. One electron. If you ask him, give me E by 2, half of the electron, is it possible? No, 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 no. E divided by 2, not possible. Why? Because this is the smallest charge that exists. If you ask him, give me 2 electrons, yes. If you ask him, give me 2.5 electrons, no, not possible. If you ask him, give me 3 electrons, yes. Give me, sir, 3.75 electrons, not possible. We say these are not possible. Why? 3 electrons is possible. 0.75 is not possible. Okay. And I can say similarly, sir, we can say n times of E. Sir, n can be 1, 2, 3, 4, so on. Okay. So what is the charge that is possible? So possible charge that exists is Q is equal to plus minus n times of E. Q is equal to plus minus n times of E is the charge which is possible. Okay, is the charge which is possible. Okay, this is the charge which is possible. Yes, yes. Okay, so basically n can be 1. If n is 1 means 1 electron. If n is 2 means 2 electron. If n is 3 means 3 electrons. Okay, where n is an integer. Okay. Okay, where n is an integer. I hope till here it is crystalline clear. Okay, I hope this is crystalline clear. Now, my dear friends, I have given some questions over here. This I'll give you homework. Please do let me know the answer of this question in the comments. Okay. Homework. Answer in the comments. So, my dear friends, that's all for today. See you guys. Okay. And one more important thing. For class 12th, okay, we have started the Nexus batch. For class 12th, we have started the Nexus batch. Now, my dear friends, we will be and that is for NEET 2026. So we will be starting from the scratch when it comes to this particular batch. Make sure you join this batch. It is very much important. The link is in the description below. And right now, maximum discount is going on. You can use my code Yawar in order to avail the maximum discount. The link is in the description below. Click onto that link and join this particular batch, okay, which is specially for class 12th, okay. Those students who are moving from 11th to 12th, they can join this particular batch, okay. This is for those students only. So take care and bye-bye. Make sure you have liked the session. So see you guys very soon in this particular batch. Link is in the description below. Take care and bye-bye. Thank you.